episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor. Welcome, everybody, again to another episode of our show. We're bringing you another really fascinating guest today, helping to create a better tomorrow on many unique fronts. And as listeners and viewers of the show know, I sit here on the United States East Coast in the city of brotherly love, Philadelphia, Pennsylvania. And I really love profiling local companies, innovators, and thought leaders throughout the STEM disciplines. And that's why I'm so excited to be joined today by Jiren Parikh, who is president and chief executive officer of a company called Ghost Robotics, which is a fascinating local group that is developing agile, all-weather, unstoppable autonomous four-legged robots, also known as quadrupedal unmanned ground vehicles, or Q-UGVs, which offer superior operability over wheeled and tracked devices on various unstructured terrains and rough and demanding environments, and now have a place in a broad range of government and commercial applications, where ultimately mobile robots with four legs have the substantial advantages either over wheels, tracks, or robots with two legs. These Q-UGVs can not only manage so-called unstructured terrain very well, but they're built for demanding customers in very demanding environments, including the military, as well as homeland, industrial, energy, and mining markets, and ultimately have the ability to keep humans and canines out of harm's way. Jiren is an entrepreneurial leader. He has 25 plus years experience in building, leading, turning around technology businesses. He has served in a variety of roles during his career, including CEO, COO, chief financial officer, business unit heads, and functional leader of both business and corporate development roles, sales, marketing, and product management, as well as in board advisory and interim executive and consulting roles across numerous industries, software, SaaS, and platforms, mobile, Internet of Things. The list goes on and on. Now he's involved in robotics. It's going to be an exciting discussion. So let's get started. Jiren Parikh, thank you so much for taking the time to come on the show today.
Well, it's a pleasure. Thanks for having me, Ira.
You know, it's I'd love to start things off before we get into everything, just to talk a couple minutes about you. I'd love to hand you the floor just to if you can give us a little bit more about your background, sort of, everything from where you grew up, how you got interested in sort of the STEM the world of STEM, and a little bit of your early career journey. I think that'd be a great way to get things going.
I'd like to start. I have three young kids. I mean, two of them are now early 20s, and the lesson I've been giving them over the last decade is be on the right side of the tracks. And I think as we move forward, I think that's kind of a message to stay in the science, STEM side. Everything, you can't do anything today without being involved in science and technology. And math is really fundamentally the language of the universe. So I always tell everybody's kids, and if you've got young folks listening, stay on the STEM side. This is the way to be on the right side of the tracks in the future. So, yeah. For me personally, I wish I had this illustrious background. People here ask me, boy, you built a really incredible robot. I have to say, listen, I have a high school diploma, and I wish I built that robot. But I did build the team that built that robot. So I take pride in that. I am first generation that grew up here from India. My parents were not on the right side of the tracks in India, northwest Indian state of Gujarat, farmers and traders that came here for a better life. I know my father came here to Fargo, North Dakota, to get his college education. They were handing out scholarships from Fargo, North Dakota to Gujarat, India, where it's just blazing hot. And so my father came here in the late 60s. They had enough money after a couple of years to fly me and my mother over. I guess that's how poor my father was when he came here. And, he made a great life of himself in the pharma business, much like your background, Ira, but he did not graduate to podcasting. And so I grew up on the East Coast, New Jersey, of course, which is big pharma land, near Philadelphia, near Piscataway. Also grew up in Detroit, where I think Warner Lambert was headquartered once, yep. Connecticut, New York, primarily the East Coast. And I was really good at science when I was growing up, probably not an attentive student. And I also recognized that I was really good at skiing and backcountry hiking and climbing and so forth. So I tried to make a career out of it. And I was sadly, my eyes awoke, and I realized that I'm never going to be a pro. And I actually ended up having to get a sales job. And the first job I could get without a college degree was inside sales. And so I took an inside sales role selling printed circuit boards. This was 1989. So I'm dating myself. And, I parlayed that into a field sales role.
Mm-hmm.
And they said, hey, we've got good news for you. And the company was in Colorado. They said, we've got an opening on the East Coast. I said, that's awesome. Do I get a salary? And they said, no, but you have to move. So I was commission only field sales guy. And I moved to the place where I knew the best, Philadelphia, because I happened to have some friends here. And so that equated to free room and board. And so I came to Philadelphia in 1990. I built a small rep firm. I ended up meeting some brilliant engineers that were working on optical storage problems using CD recorders. Most people don't even know what a CD recorder is, let alone a floppy disk.
I do.
I parlayed that into a small business called Electrosun. We sold it to a Dutch company. That was my first exit. And I was in my early to mid 20s. And so then I caught the bug.
Yep.
And then I was very fortunate to work for a company called Infonautics. This was the early days in digital internet content. It was just a great team there. It was a couple hundred people. I worked for a guy named Josh Koppelman, who's just an absolutely brilliant product guy, brilliant businessman. And he went on to, found half.com and First Round Capital, and just a really good experience for me in Philadelphia area. And I've never left. I had got married, had some children, got divorced, had more children, and I've never left Philadelphia. I love it. It's been good to me personally and my family. And I can see this next generation tech outside of digital, right? We have the Comcasts, and we had, surrounding Montgomery County area, there was a lot of these software application tech companies, telecommunication technology companies, hatching, Conshohocken into KOP area. And now all of a sudden, you're seeing this brash new portfolio of startups that are in a complex engineering environment, robotics, right? Both UAVs, ground platforms, systems to control these robots. There's Fort Robotics here now that's doing compelling things on safety and multi-platform connectivity in manufacturing environments for robots. There's just a lot of stuff going around here. Exim Technologies, I can just keep going. So I think there's another growth phase here in kind of the next generation of tech, robotics, autonomy, AI. And so I think it's got a great future, and really proud to be in Philadelphia.
Absolutely. And you mentioned at the beginning, you're obviously very good at putting together teams and organizing the groups to make stuff happen. I was reading a little bit about the early days. So the concepts that are behind Ghost, came out of something called the GRASP Laboratory, General Robotics, Automation, Sensing, and Perception, which is located at the School of Engineering and Applied Sciences down the street at University of Pennsylvania. Talk a little bit about the history, the folks that were involved, and sort of those early days where you went in and were like, hey, let's create a company out of this thing. It's really cool what you're doing, but let's build a team and put this to work.
And when I think back, I go, my God, I can't believe we did this. I mean, it's been a crazy journey. And I've been doing software for most of my life, right? North of 30 plus years. Mm-hmm. And now all of a sudden, this hardware startup, which I've never done. So go back in time a little bit. It's early 2015. I just sold off a company that I was restructuring in Princeton, New Jersey called Snap One for some existing investors. And, we had reflated this company, took it down to 5 people I did, and then reflated it up to like 120 and ran into some headwinds, and we exited the business. Restructurings are challenging in so many ways. And so I'm taking time off, and my last child is just, is in the middle of college. I've got still a 10-year-old at that time, a 9-year-old. And my 2 older kids are out. One's working for Tesla. The other one's going to get into financial services in New York City. I'm thinking, you know what? I'm probably done with these startups, right? I've been doing them my whole life. And I meet a friend of mine from Comcast Ventures. And he says, look, why don't you go down to University of Pennsylvania? They have an innovation lab, Penn Center for Innovation.
Yep.
I meet a really friendly guy, Michael Pozell, who's been around the VC industry for a while. And they've got a portfolio of tons of companies, software companies, graphene companies, robotics companies. I mean, it's just crazy. And I went through this list, and really only a few stood out. And one was Ghost Robotics. They built this cute little Minotaur robot out of parts in a lab, 3D printed, some aluminum CNC material. And you can check it out. It's a Minotaur. We have a couple videos of it. Gavin Cantley and Avik Day, 2 PhD candidates at the University of Pennsylvania, had built this robot. So I took a look at this robot and I said, I don't know anything about robotics, but what they said was really fundamentally amazing. They said, that company, Boston Dynamics out there? I go, yep, everybody knows it. It's owned by Google. And my advice to you is, if you're trying to take them on, you had better have a good story. Otherwise, Google's going to crush you. And they had a story. And those are one of three ingredients I look at when I meet these brilliant technicians, technologists. One is this vision. And they had this vision. They're very humble about it. And it was, look, these robots look great on video, like the Spot quadruped robot, but they don't work very well in the real world environment. And I got it. And they had a brand new way of making these robots work. And it was fundamentally at a fraction of the cost when you're scaling it. It was a completely open platform, and anybody can do anything you want with these robots. And I was like, wow, that's a tall order, but I bought that one variable. The second variable was you need training and background experience, right? Might be an entrepreneur that worked 20 years at Glaxo and you have a better way of doing drug discovery. You need that variable component in there.
Sure.
These guys have been working on this electronics and the core underlying strategy on biomimicry for close to a decade. And they're brilliant, right? They had, both had great pedigrees from top universities, Johns Hopkins and McGill, before they got to Penn. And the third thing was really grit. This capability of withstanding severe pain, shock, and disappointment. And not just once, but twice, but over and over and over again. And can you get up the next morning and not say F it and keep pushing? And I said, these two kids have it. And I call them kids, but they're young adults, but half my age. And I just decided to get into bed with them. And, the first $100,000 was mine, right? My credit cards and, just that whole launch of a new business in late 2015 based on this premise that we could do something. I didn't even figure out how we're going to even get the $500,000 to $1 million to even just build a ugly first generation prototype. And now we're 15 prototypes ahead now, where we finally have a commercial ready robot. 15 prototypes. And if I tell you this young team we have here, now we have about 31 folks working 14 hours a day, 6 days a week for this mission, for this vision that we're going to build this robot. But the second piece of that vision is we're going to build it for people to keep them out of harm's way. We're going to do good and to do it for our government customers. And as I say, and I said in my IEEE article, all these people that do the work on behalf of our country and national security for not much pay, not much recognition, really can't tell anybody what they're doing. And so to have that mission and capability and then put your foot down and say, I'm going to do this until the very end and not quit until we have a viable business, it's really challenging. And for me, this was my biggest challenge because it was hardware. And it's not like software where the night before you could maybe bubblegum something or chicken wire it. You literally have to wait weeks for prototyping, and it's very expensive. And this was an awakening for me. But I believe what we built here is just fundamentally the most incredible piece of technology that I've been involved with in engineering project.
And when I go to the website and I sort of look at the different classes of the the core, I guess the core model. You have the Vision, the Wraith series, and then the Minotaurs you were mentioning, and sort of the way my sort of pharma mind thinks of this. Okay, here we have the Vision, very challenging environments, your mining, oil and gas, and infrastructure and so forth. Wraith, even more challenging. I think he's sending that off to clean up the Chernobyls and places like that,
Right.
military zones, and then jokingly around the Minotaur. This is the one that my daughter it wants for our house. She's already asked me about it. I always give the background of our guests to my kids, by the way. Walk us through a little bit about sort of which of these came first. What's what are you mainly focused on? All three of them. One versus. Walk us through a little bit of the three options.
So our primary robot today is the Vision series robot. It can be used by government, military, homeland security. It's used by Verizon on a number of inspection projects. They're building out a solution to offer the market. We work with a lot of vertical companies like Area Security. They do like 65% of the security solutions for nuclear power plants, right? Now they're going to use our robots for perimeter security. It's an all-in-one robot that we built for these kind of demanding environments. It's IP67, it's fully waterproof, comes apart in 15 minutes. It's just a work of art. We'll talk about why our robot's different than a Boston Dynamics or any other legged robot in the world shortly. That's our primary robot today. And now we're going to start building different sizes. That's a Vision 60 because it's 60 centimeters from hip to hip. That's how we measure our artificial animals, hip to hip or motor to motor. Okay. We're going to be building a Vision 40 centimeter, and then eventually 30 centimeter. So a lot of different smaller robots coming out. The Wraith is really military specific. That's a robot that'll come in the future that will be, export control. It might have redundant electronics because a warfighter needs it. It might be ultra quiet because the warfighter needs that robot to be quiet. It might have extended endurance because it's using certain types of fuel cell technology to operate. Things that make a robot very, very expensive and useful for certain mission critical or clandestine or other types of operations. But something a mining or construction or manufacturing company or a general government customer is not going to spend the money on. And frankly, that's kind of be a high-end niche product. The Minotaur really was our experimental lab product. That was the robot that we used to convince people, hey, give me cash because I'm going to build a real robot. Hey, by the way, check out my little guy. What do you think? And, it's super exciting because you see that robot climbing fences and jumping around. It's cute. We have a version of that robot today that's more modern. It's called the Spirit, the Spirit series robot. And that Spirit series robot is now a replacement for Minotaur. It's a lab robot. You can buy it for 30 grand. God, we can't keep them on the shelf. We sell them worldwide to universities, research organizations. We also sell them to government agencies. They're doing experiments on the next generation of smaller Vision robots that will come out. That's kind of how we've identified the robots. And, our marketing guys have really cool names for robots that swim and robots that maybe walk and fly. I don't know. I can't disclose everything in our bag of tricks, but these guys are thinking of some really cool robots that'll do some amazing things in the future. And it's just exciting to be a part of it.
And just thinking of the Spirit series for a moment, just because we do a lot of episodes on sort of the smart home, sort of healthy aging topics of this nature. And we've had some folks on from like General Electric, Shark Ninja, obviously sort of early generation stuff, but any possibilities? Are you thinking of sort of the home use? Once again, okay, $30,000 now. I got to get that one for my daughter. But for sort of aging in place and sort of some of the home-based opportunities for this particular niche. I mean, obviously, I know you're focused heavily on the industrial side of things, but anything on that particular front that you guys sometimes sit around and blue sky?
We do, and we do have ideas for, right? So I think the challenge for a small company like us is our number one priority is government, U.S.
Sure, of course.
Second priority is kind of large industrial companies, that can afford this type of mission critical robot, right? And our robot is a lot different than any other legged robot out there. Not to beat up on Boston Dynamics, but just the design of it, repairability, ease of use, programmability, but it costs money. And customers that can buy this type of technology are typically government, military customers.
Sure.
And we see within 36 months that switching, that interest level, switching into industrial and enterprise will start scaling.
Good.
An industrial company can buy 50 or 100 at a time to do autonomous tasks.
Yep.
We see a decade from now that prosumer market, and then we ultimately see a consumer market where these robots are less than $3,000 or $4,000.
Got it.
Now, what are they doing? It's really, when I try to describe this to, let's say, my family member or my father, hey, my dad is like, what are you doing these days? I go, well, Dad, I have what we call a computer with legs on it. And basically, that's all our robots are, is basically an edge processor or a computer with legs. We're just trying to move that sensor or the radio or that edge processing to somewhere in the field where it needs to be, right? Whether it's inspection in a plant with a sensor, or it's in a combat operation, providing target designation or cameras, or in our case, whatever other payloads that we're developing for our government customers. You're really bringing the computer into the wilderness or into a manufacturing plant that can move around where other fixed assets are sitting and be flexible and operate around them. And so ultimately, that's what we're trying to do, is build these different walking computers of all different shapes and sizes and give people the capability of doing processing and collecting of data at the site of where they need to do it.
Excellent. What I watched a video of you. I think it was at one of the Amazon Web Service summits or conferences, whatever. And you were talking. Sorry, again, you're talking over my head a little bit, but you're talking about edge computing, the cloud. I know there was a Verizon. There was a conference with Verizon recently where they talked about your robots in terms of 5G connectivity and sort of 5G in the air, some wild stuff here. Walk us through a little bit of this stuff. Once again, I am apologizing being a pharma guy if I'm asking sort of the kindergarten questions here, but take us through some of these, the software side of this and some of the things that you're looking at, obviously the things you're allowed to talk about, understanding.
Yeah, and I'll share a video with you too later that you can post for your users.
Sure.
Like a quick recap video of our robot doing all sorts of cool operations in the field.
Yep.
And when we always show our videos, they're never canned. There's always a customer behind the video when we show anything online. Yep. So any of your listeners or customers, they go to one of our Twitter, Instagram, or whatever. The robot is never canned. We always show the robot operating with customers behind the scene to see what it's really like. And so let me start with the basic. Fundamentally, legged robots are very similar to robotic arms that are in a factory putting a car together, okay? These arms move very fast. They're very deliberate, right? And the whole idea is they move in these pre-performed motions, and they weld or they paint or they put body parts together. If those things hit a human or something they're not supposed to hit, that's a bad day. They shut that quote unquote cell down. They reprogram it. They figure out what happened. Why did the robot do this? Think about a legged robot. It's constantly hitting and colliding with things. It's basically walking and it's just doing collisions continuously. And so typically legged robot manufacturers around the world, there's 40 or 50 universities and research and commercial organizations around the world that are building or trying to build legged robots. The robots have to have the ability to feel the environment, to know what their next step is. So typically robots have sensors in the toes, right? There's a force sensor. Oh, I hit something. Now I'm going to take another step. What should I do? And they operate with vision. These are both forms of what we call proprioceptive sensing. Bringing in sensor data, and then knowing what to do. A lot of these robots, like Boston Dynamics, Antibiotics, they operate with vision. So sometimes these robots, in fact, these robots don't do well when there's tall grass or confined space because they get confused. They also use sensors in the legs or the output of the motor, or they use a clutch. And they all use harmonic drives. There's a sole source for harmonic drives. Very small motor, very large gearbox. So you give it a command, the motor moves, the reduction system, it's like, 100 to X to, those types of ratios. And so they can't really feel anything through the environment. They have to feel it through the sensors or the vision. And if they don't see it, or if it's operating at high speed, or if a robot is on ice, we have a video of our robot on ice.
Mm-hmm.
How does a robot know what to do? And that's why they look great on videos and they constantly fail.
Mm-hmm.
They need vision and force sensors in the legs. Our robot is a standard BLDC motor. Translate, it's a standard drone motor used in quad rotors. You can buy it off Amazon.com. It's not a fancy, expensive harmonic drive. It's also got very little gearing around it. It's almost like we're directly feeling the environment through the motor. So the motor is highly backdrivable, goes back and forth very quickly. And we're just measuring our environment forces as we push the robot takes another step. It's actually measuring and feeling everything directly through the motors. And the motors themselves are sensors. That's one of the fundamental unique value propositions of our robot. Our robot uses the motors themselves as sensors. And so now we're measuring forces to the robot. When you push the robot, it kind of balances itself and it kind of pushes back towards you. It's basically like fidelity of life, and it's measuring forces at 2,000 instructions per second throughout the robot. There's 12 motors in it. So it's really amazing when you push our robot, you touch it, it's springiness, it's all software springs. It's like life. If you had a dog next to you and you push that dog, he's going to bounce back up and kind of nudge back to you. Same thing our robot does. So when our robot is moving through unstructured terrain and it slips, it's measuring all those forces and then reconfiguring itself to stay stable, which is why our robot, time and time again, when we test it against Boston Dynamics and virtually every other legged robot in the world, our robot is far superior. It even climbs stairs, not knowing stairs are there. Just taking minute changes of forces, angular momentum, changes in the inertial measurement unit, all the different pieces of data that we're getting and fusing and saying, hey, I'm going at a certain angle. It looks like I'm climbing stairs. Keep this motion going. But it's like life, just like your dog or you are trail running through the woods. You're constantly updating and balancing yourself, and you're staying stable. And that's what we programmed into our robots. And it's just absolutely amazing technology because nobody else is doing it. That's the fundamental basis. Second is we decided our robot must be completely open. And I mean completely open. Any software, any AI, any sensor, any radio to operate the robot. Now, why do that? Well, I've been doing this for 30 plus years in enterprise, and no CFO at a large company wants to write a check to a small guy unless that CFO knows, hey, is that platform open? Nothing personal, but if you go out of business, I want to make sure somebody can use it, program it. It's got APIs, is it well documented? Mm-hmm. Is it well written? Do other people understand it? You have partners, systems integrators, Accentures, whoever, that know this platform, they can integrate it and support it, right? And so we've taken those lessons as an enterprise company or people that have been in the enterprise space and said, our government users need that same thing. They don't need to buy a robot where even if they have to come back to us for even a fastener. And this is the standard model in defense contracting, right? Everything is proprietary. Everything comes from you. By the way, they have to come back to you for everything. We just feel that's wrong on a fundamental basis on operating the company. But also, we want to make our life, the lives of systems integrators a lot easier. Sure. We want to put a platform in their hands so they can develop all sorts of cool solutions. And I can't tell you right now, pages and pages and pages of different solutions that our government customers have come up with, our partners have come up with. We want to support them with a platform that's completely open. And that extends all the way to how the robot is repaired. Okay. Typical legged robots, I'll tell you, every legged robot or arm, you have to ship back to the factory to get repaired. Or there's somebody on site that comes to repair it. My robot comes apart in 15 minutes, the entire robot. And I can do it. And remember, your listeners probably remember that I have a high school diploma. And so I can take that robot apart, put it back together again. And these are fundamental principles that don't exist in basic robotics, let alone legged robots with the complexity of wiring and so forth. A robot even works upside down. we've just done a lot of interesting, unique things on designing the robot to make the lives of our customers and our partners a lot easier. And this is one of the lessons we've learned from the startup world. You got to move fast. You got to move quick. You got to build something that can scale. And if you want to beat the big guys, build a global ecosystem of partners that are building solutions around you. Because now you're not only valuable to the end user, but you're valuable to a whole ecosystem of partners. And people like Cisco have done that very well. Other channel driven, companies that are channel driven, Microsoft has done a tremendous job over the decades evangelizing and building these channel partners and value added resellers and systems integrators. And we're no different than any other type of Silicon Valley company that wants to grow quickly. We have to not look at just the commercial models, but we fundamentally have to look how we're designing the robot from scratch.
Really very cool. An amazing program and ecosystem you build around it. I take my hat off to you for everything you've done here so far.
One thing that we talk about endurance. Typical robots work for less than an hour. Typical legged robots work 45 minutes or less. Virtually everyone out there. Our robot runs 3.5 hours.
Nice.
Continuous walk time at a meter a second. Why? The entire robot runs on a 1-watt microcontroller.
Okay.
The entire robot, the compute board, the bus board, even the motor controller electronics, even the electronics that run the battery, everything is custom. Also, everything is US and Allied made. Now, it's very interesting, that design principle of energy endurance is everything. A legged robot that's fully autonomous that dies in the field after 45 minutes or an hour is completely useless.
Sure.
No matter how compelling it is. So our robot does anywhere between 6 to 8 miles on a single charge. Now you can put AI in there. You can put autonomy in there. The robot can do a job and come back. We also made our wireless charging system, our charging system wireless. So you can put it outdoors in the pouring rain.
Mm-hmm.
We did a lot of small things over the last 5 years to get to our commercial ready robot today that many other people would not have. So for us, our minimum viable robot had a bit of complexity in there just simply because of our customer, the U.S. government Department of Defense, companies like Verizon, companies like Ares Security, Carlson Software, big vendors, right, in mining and in 5G and connectivity. And we did a lot of other things, like the robot has Wi-Fi 4G LTE already built in. And now we're adding 5G next year. It'll be built in as a baseline robot. You don't have to think about it. Now, our government customers are using special government radios. They're using military radios. By the way, there's a switch in there. There's a fully integrated router. You can plug in a Starlink satellite connection and you'll be operating through a SAT. And so the robot has a lot of robustness that you don't see in other legged robots out there, or any robot for that matter. We just wanted to make the experience for the customer super easy.
Jiren, you brought up before, you mentioned both autonomy and AI, and I wanted to touch on obviously the recent story guys got a lot of press with the collaboration with this group called Sword per the special purpose unmanned rifle. Obviously, there's military applications here. I get it. Everyone gets it. You made a point in the news. This is not autonomous. There's no AI behind this. This will be controlled and so forth. And we've done episodes with the military, and we've learned about on the wire, off the wire.
Right.
You can talk about it. And I personally have no problem with it. I think it's great to keep a soldier out of harm's way, a canine out of harm's way.
Listen, and if you don't want that robot harmed, my advice is send your daughter or son. Exactly. Take over that robot. Let's see what your decision is.
We're on the same page. I was coming from a different angle, and please, you can talk about the other topic as well. I was your floor, but I guess your vision of where it potentially goes. We do a lot of AI shows as well. Where do you think you want to take this in terms of, and not the rifle bit, but in general, the autonomy, the AI, looking out the next 5 years, whatever.
Let's talk about these robots, right? You see them on videos. I'm going to share a MASH video with you for you to send to your viewers. So the robot, who's behind the scenes? There's a guy with a remote controller, right?
Yep.
There's a guy with a remote controller. He could be 100 feet away. He could be 1,000 meters away, right? 3,000 feet away. Depends on the radio you have, right? We operate these robots sometimes over a mile away, right? We operate in subterranean environments in New York City or other areas where, it's mission critical. Bad people can be in our, underground in a city doing bad things. You need these robots to do inspections and things. Yep. You can also operate these robots from 3,000 miles away, just like you would operate a drone that's high up in the altitude. So that's what we call remote controlled or teleoperated, right? There's a man in the middle. The man is operating it. It doesn't do anything without somebody turning a joystick. Now what we call semi-autonomous systems. Semi-autonomous systems is, hey, I've given the robot a GPS waypoint. I need to go out in the field 2 miles, take a left, right. I'm giving you non-technical lingo here, but somebody's going to be saying, hey, I wanted to go to XYZ coordinates. It's what we call semi-autonomous. The robot's going to run into a large rock, or let's say it runs into a tractor trailer that pulls into the parking lot at a manufacturing plant. Oh, it wasn't there yesterday. The robot has object avoidance, basic AI to say, hey, that's a tractor trailer in the marshaling yard. Mm-hmm. My route is to go inspect that next, warehouse. There's some asset piles there. I want to check out how much inventory we have. The robot's going to go around it, right? It has some basic level of autonomy and knowledge based on computer vision and perception, right? Mm-hmm. And cars are doing a little bit more sophisticated autonomous processing there, but it's really semi-autonomous, right? Because there's a man in the middle there, and before it does anything really crazy, the robot's going to be like, I'm not sure what I'm doing here. I think I might run into that garbage can going around this tractor trailer. Let me alert my operator. And the operator's there at the screen and says, I'm going to help the robot go around the garbage can in a little bit of a maze to get to its next point. It'll go back to what it's doing. Then there's fully autonomous operation, right? That's where, let's say we let this in a subterranean environment, and I grabbed a cup of coffee and a cigarette and said, hey, robot, do your job. Okay, that is a long, long, long time away. That type of autonomous operation is really complex and difficult. We can't even get vehicles to operate on roads, and we have a set standard of basic objects that it needs to identify. Sure. It's really the edge cases. You don't want to hit somebody.
No.
What happens when the sensors fail? Is that a shadow of a child, chasing a ball in the road? It's all the edge cases that are painful. Mm-hmm. And so it's no different for a robot that's in unstructured terrain, right? He could step into a grass field. That could be a 2-foot ditch. How's it going to get out? A lot of challenges there. And so semi-autonomous operation is the name of the game today. The second thing is when governments are using these robots, there's always a man in the middle, we call it, mm-hmm. man in the loop. Mm-hmm. Why? The robot has to take some sort of combat operation action, targeting, lasing, sensing something, or firing a weapon, right? Yeah. None of these systems, in the US or allied arsenal are without a man in the loop.
Sure.
It just doesn't happen. And if most people know, and by the way, our government is not perfect. Nobody ever is. As you grow up, you realize there's no black and white. There's just a lot of gray.
Sure.
I got to tell you, the United States and our key allies, we're overly cautious, right? We will wait years before the Chinese or the Russians or somebody else does something, because we won't just follow. We have this rigorous process of discussing, arguing back and forth before we do anything, even in combat operations. And a lot of U.S. soldiers and Americans and allies have given their lives to do the right thing versus doing the most expeditious thing. And we should all be proud of living in a country like that. So yes, these robots always have a man in the middle. No triggers are ever pulled. And by the way, robotic systems in the government side of things, they've been around, like I said, for decades and decades.
Sure.
A precision guided missile that's fired halfway across the planet, that's a robot.
Absolutely.
It's a lot better than carbon bombing.
Yep.
Predator and Reaper drones, were originally designed for ISR. They decided, hey, by the way, instead of dropping tons and tons of bombs from an high altitude plane, where we have a lot of collateral damage, the amount of assets and cost is expensive to drop these bombs, but also we're hurting people we don't need to. And so we've gone to these precision guided weapons, and you always hear about the collateral damage on one or here and there, and that's good, right? It's the media and journalism's responsibility to hold us to task. But the amount of collateral damage has been reduced substantially. We think of a sniper kit that's really used by special force teams to take out really bad people that could have some really bad impact, from a WMD, C-burn, or hurting innocent people or our troops. Having a weapon like that that's very precision actually makes sense because you're reducing any type of collateral damage. You're also supporting the mission of the United States and the allies by not only doing what's right for national security, but also reducing harm to people that may be at the wrong place at the wrong time, right? We're always worried about that collateral damage impact.
Mm-hmm. Yep.
And I'm proud, in that sense, I'm proud of being an American. And
Me too.
I think we should all recognize the military has a job to do, and they don't savor it. They do it because they need to. And if we can make their, life a bit easier and make sure their families feel that maybe they're going to come home, reduce that stress load.
Yep.
I think that's our responsibility.
Absolutely. Couldn't agree with you more. One more question on this point, and here's maybe a silly question, but obviously I saw that one of your projects is patrol. I think the Vision robots are going to be patrolling Tyndall Air Force Base in Panama City, Florida. It's thinking of when you regularly have a sort of an attack dog or a guard dog doing something, right? They can signal, hey, there's a bad guy here, but they could also jump on them and bite them. Is there ever has everyone asked you to create one of these robots that, minus the rifle, that can actually, I don't know, fight or jump on somebody and stop them from doing something? Or is that just a...
So let's step back. Let's say I'm one of your viewers.
Right.
Just a normal guy. You just pulled off on a car on the side of the road with your, with your recording system. Hey, I want to ask you a couple questions. You've got a system to keep your base or your house secure.
Sure.
Somebody tries to break in. Should you have the right to punch him in the face and tell him to stop it? Yeah, I think so.
Yep.
Should you be on a military base where the signs are pretty clear, do not come, at X feet or whatever, and you still do it? Yeah, you probably deserve a slap in the face for coming up there. But the government here, our military users that say we need to protect these military bases, our robots are doing autonomous security patrols, right? They know a GPS waypoint, they operate, they see a car, truck, vehicle. They're really just messaging back to a security personnel in the base defense operations center. Hey, there's a bunch of intruders at gate B. But do you know our government is very cautious? They don't want the robots to harm or do anything. It's interesting how we think about it in this country, how we're always a little bit more cautious than not. And I think that's a good thing, right? We're not here to harm somebody. Right. Maybe somebody stumbled onto federal land. I don't know how, but I guess it happens. We're not here to punish people or hurt people. We're thinking of that robot as a tool. It's gaudy, it's loud, it's got a speaker system on it, it's standoff. We're actually telling people, hey, don't come any closer, go back to what you were doing. And if you're here by accident, please leave.
Right.
This is a restricted area. So the Air Force, a lot of other folks like nuclear power plants, Department of Energy, they're looking at it and saying, we just don't want people here. This is not a place that they should be. And we want to warn them off. We don't want to take any physical action. Does that make sense?
Yeah, complete. Yeah, perfect.
Sometimes you see a security guard outside of a building.
Yep.
Don't mess with us, right?
No.
The security guard here, don't mess with us.
Get away from Area 51 too.
Yeah, correct. I think that's what they've been looking for us to do. In fact, they want the robots to be loud. They don't want them to be quiet. Right. Some of the customers want to blare music from them every once in a while.
Nice.
Let people know that, hey, this is an area that you shouldn't be in. Quite interesting. The opposite of what you would think.
Interesting.
So if you combine that with most normal people, I would say, people that you would ask, hey, you're trying to protect a mission critical asset of your home, they'd probably say, hey, you have the right to, take it upon you to, get rid of that person that's on your property.
Okay.
Most of the messages we're getting from the enterprise and the government spaces warn them off so they don't come back again. That's really the key message.
Got it. Jiren, I know we're coming up to 3 o'clock and you have other things you have to be doing, but before we lose you today, I just, we're almost to 2022 now. Can you just, for a couple of minutes, just take us on any big plans that you can announce? You're hiring, what type of people you're looking for, any fundraising you're doing, and anything else you want to mention about the company and what's happening next year, please take the floor.
Thank you. So first of all, business is off the hook. We're very fortunate. We're hiring as fast as we can. So we're looking for electrical engineers, firmware, controls engineers, software, field application, you name it, mechanical, systems integration engineers. Our expectation is we're going to be hiring very rapidly now over the next 12 to 18 months. The company's now moving to the Navy Yard, by the way, from
Awesome.
Innovation Center. So we've got some Class A space there. We're super excited. We're not only just expanding our business with, our U.S. government business is big, but our business is substantially growing in Europe now. Pilots deployments throughout Europe. We just announced something with Singapore. We're going to be building solutions with the Ministry of Defense there. We've been building solutions with the Ministry of Homeland Affairs for several years. We're going to be expanding into Asia very rapidly. Over the next 6 months, we're going to be making a number of big announcements. Different size of robots are coming out. Just a lot of excitement here. And then the last thing is we're starting to see an interest level from enterprises. It's very exciting around inspection, persistent security applications. And that gives me hope that this is going to be big, right?
Yep.
Because the government is an important market, first adopter. They can help flesh out technology to commercialize it. But really, as we get into the enterprise space, this is going to be a massive, large-scale market opportunity. And we fundamentally see that legged robots are going to change the way how ground robots are looked at. Today, there's this perception that quad rotors, they're inexpensive, they're simple, you can deploy them in volume, and you can do so many great things, right? There's uses and applications. And I think we want people to see our legged robot as the ground drone, as the kind of a similar type of product as a quad rotor. And to get that message across, it's simple, it's easy to use, it's low cost. We need greater adoption, a larger base of use cases and applications and partners in the ecosystem helping build these solutions out with end users. And I can see that happening now. And I'm very, very positive on the number of inquiries we're getting worldwide on the enterprise side. So we think we're going to be a business that's supporting both the government as well as dual use enterprise customers.
It's going to be exciting to continue to follow you and everything you're doing. And I got to tell you, I'm wishing you the best as you continue to build this fascinating company. For everybody that's going to be listening to this episode on the podcast networks or watching on the YouTube channel, you've been listening to Jiren Parikh, President and Chief Executive Officer of Philadelphia, Pennsylvania-based Ghost Robotics. Jiren, thank you for taking the time out of your schedule to come talk and educate us all. Thanks for everything you're doing there. And as we say on this show, thanks for helping to create a better tomorrow through the development of these technologies. A really fascinating story.
Thank you, Ira. Thank you. And I'll send out the link for the video you can share with your users.
Yeah. We'll put all that in the bio to the show.
Okay, great.
Great seeing you.